Hello, PerfBytes listeners. Before we begin, please take a moment to listen to a word from our sponsors.
Whether you want to load test your APIs or your browser-based applications, you need to be able to easily scale up volume and identify problem areas. SmartBear has you covered. LoadUI is the rock star of API load testing. Using an intuitive, versatile design, LoadUI gives you the power to scale up and out, letting you dial up high volume and real-world load from any number of local and remote computers, all within a single test environment. With LoadUI, it's easy to create and configure tests, incorporating all of your operating system, application, and database statistics agentlessly. It's fully interactive, too, so you can easily modify your tests and fix errors on the fly. Load Complete is an astonishingly easy-to-use load testing tool for HTML, AJAX, and rich internet applications. Create and run automated load tests in just minutes using a browser to naturally record your interactions with the website or application. You can scale up the number of virtual users, pull in data from Excel or other data sources, monitor server resources during test execution, and even distribute your test geographically. Load Complete's reports and charts make it a breeze to explore aspects of how your site or app performs under pressure and ultimately pinpoint performance issues proactively. LoadUI and Load Complete by SmartBear ensure outstanding performance across your entire web stack.
It's time for PerfBytes.
What the is PerfBytes?
The fourth square meal of the day. Don't bogart the PerfBytes.
Waffles.
Microwave ready. Blah blah blah. Add nutritional value to your brain. It's time for PerfBytes with your hosts
Mark Tomlinson, James Pulley, and Howard Chorney.
PerfBytes. Whatever.
Hey, greetings, listeners of the PerfBytian persuasion. Today's episode, of course, is going to be delivered, if you didn't know it, directly from the brain of our newest co-host and PerfBytes founder extraordinaire, Howard Chorney. Howard, how are you?
Well, Mark, I'm just fine this evening. How are you?
Now, you're up in the Boston Northland getting frozen and under a bunch of snow, aren't you?
Oh, yeah, we've been pounded. We're talking 5 feet on the ground in my backyard right now.
Get out of here. That is insane.
It is insane. The dogs are, the only way I can even tell the dogs are out there, their tail kind of sticks up, so it looks like Jaws in the water with the dog's tail sticking up like the dorsal fin of the shark.
You should get out the keyboard and play the little doo-doo, 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 doo-doo. Exactly. You know, it's kind of a stress test, too, if you think about, like, the roof, if there's snow on the roof.
Yeah, and failure would be pretty catastrophic in that particular.
Pretty much, that'd be a hell of an outage. Of course, also joining us is our good friend and confidant, James Pulley. James, in the Southland, where snow is just, I don't know, do you even know how to spell snow down there?
I have a bunch of neighbors who wound up living in this area because they were driving south and they kept getting out of the car and asking, do you know what kind of thing this is? And they were holding up a snow shovel.
Oh.
And when they got far enough south that they got an answer that was wrong, which was, oh, that's a leaf shovel, they stopped and decided to live here.
Well, they must have been past Charlotte, James, because you know damn well I spent the whole winter there last year on one of my client sites, and there was plenty of snow.
Oh, yeah?
Oh, yeah.
Yeah, that's because it comes down with you guys.
It's my fault.
We never had snow here before people started moving south from
Yeah, and I don't think the TSA has a limit on the amount of snow that you can.
As long as it doesn't bring down a plane, they don't care.
Exactly, and it goes through the X-ray just fine. So the next time you have a large ice cube and you go through X-ray, don't tell them. Yeah, they'll figure it out.
Yeah, just make sure that ice cube is less than 3 ounces, or they won't let you bring it on your carry-on.
Very good. So, Howard, you've offered up a topic for this episode, which in long form is 10 things every developer can do to improve application performance. Now, this is a paper you've written in a culmination over a couple of years of study, but this is like a different perspective from the episode that James and I did last year, which was just sort of generally about developers doing performance testing. This is kind of your difference between testing and engineering. Where did you come up with all of these things?
Mark, let's start talking about this for a minute, because I am the disciple of performance engineering versus just performance testing, and I've always been an advocate of folks in our discipline, performance engineering discipline, who happen to do a lot of testing to expand their base and become one with the developer community, and teach and talk and not just preach, but offer some value to the community. Yes. So,
and also, if you actually owned a pair of Birkenstocks, you could almost be you could be more than a disciple. You could be like the Jesus of performance engineering.
Well, that's kind of funny, because you know what my nickname for Birkenstocks are? What? Air Jesuses.
Air Jesus. Hey, no offense to actual Christians, Jesus was a cool cat, and if he could have Jesus Airs with Nike, they'd probably have a building named after him.
They probably
Jesus
would.
Jesus Christus. Jesus, the Nazareth building. You'd have all your meetings in there.
So anyways, just after by getting back on topic, which is no fun, but we'll do it anyways. Getting back on topic, it's just years and years of being in the industry and working on a lot of different apps and working specifically on consumer-facing websites as of late. I mean, this is really important stuff. Yeah. And so I just kind of put these 10 things together and actually presented them to a couple of companies, and they've gotten some traction. So I've actually got some validation that maybe my head isn't up my backside on this.
Great. So inviting James into the conversation a little more. Would you like to? You and I will just do a rebuttal as Howard kind of offers up his thinking in these different things. So Howard, kick us off. What's the first one you're thinking about here?
Well, the first thing I'm thinking of is, we need, as a development community, we need to set superior performance goals, right? This can be accomplished by setting performance targets to shoot for. And where do we start? Let's just start with, if you don't have SLAs, or, people are just clueless when you say the word SLA, it's like, let's go look at industry averages, all right? And industry average states that a service level agreement / SLA should be about 2 seconds from screen to screen when navigating through pretty much static content. Maybe you'll have a little bit of dynamic content on it, but you should be rendering your screen within 2 seconds. So developers should be setting a goal to do that. Yes, and I will admit, then when you're passing off to a third party, doing something like a credit card verification, fraud verification, or something like that, it's going to be a little more than 2 seconds. But this kind of gets to the things that are in your control and out of your control. But when things are in your control, set that performance goal and then shoot for it and hit it.
Now, thinking about this 2 seconds, James, I think about human factors, right? So even if it's a screen, let's say you were in a World War II aircraft and you had something printing out on a radar, like radar updates, they did a lot of studies of cognitive psychology and recognition and perception. 2 seconds is not just this casual thing we throw around. There's actually quite a bit of usability study behind this 2 seconds.
Well, I just want to go on record saying, since we're supposed to be the counter to Howard's statement, Howard, you're full of crap.
Beautiful.
Why, thank you, James. I appreciate that comment.
We all know developers do not want to set performance goals. Functional is easy. And you know what? Marketing is asking for 15 different integrations with different tracking sites for Division A to get different stats in Division B, to get different stats in Division C, because they all have their own unique thing that they like to look at on the World Wide Web for the stats that they want. And you know what? I think this is an ideal. I would love it to be true. I would want it to be true. But I think this is a pack of really weak fertilizer. It doesn't even have good enough strength to grow.
Well, no, let's defend Howard a little bit here. He's saying you should be setting performance goals. Not that people do this.
Okay.
Yeah.
Okay.
But James, to that point,
the nice caveat there. You should. Yeah, okay.
But it is. You should set, if you can set performance. I think James's point is potentially people set those goals in a vacuum, and the marketing people think about their beacons and what their performance might be for their things that they want. Database people think about their thing. Network people think about their thing. CDN thinks about their thing. Partner web service thinks about that.
And you start adding up 2-second blocks, and now you've got a 22-second page download time for all dynamic elements.
Yeah,
that's funny when you said CDN, because CDN should help. A CDN should absolutely help you achieve that 2-second screen per screen.
it can help, but still, you should. I think, Howard, we should tell people, if you don't see something that says the whole page load should be 2 seconds, or the whole static content reading should be 2 seconds, find it in a user story. And a user story is a communication vehicle that everyone can refer to, not just my little piece of the world. A user's,
And by the way, that user story should be constructed before the code.
That'd be nice. Wouldn't that be nice?
Well, that's funny, James, because what a segue into my second thing.
Number two.
Spend more time in design before you commit to a single line of code.
Yes. I will bring up once again, I think it was Tom, no, it was Jim Duggan from Gartner many, many years ago. Howard, you and I were at Shunra on the phone with him, and I said, what makes the difference between performance engineering and performance testing? And he said, if you are doing behaviors that influence before all the thinking before you write the code, then you're doing engineering. If you're doing everything after you wrote the code, that's testing and validation. I thought that was a really valid perspective.
We've kind of all said it all, but they're like just on the design piece. I mean, really, how much do you have to go into engineering 101 that you should actually blueprint and design something before you build it? It just makes perfect sense. Maybe that's why it doesn't get done that often anymore, because it makes too much sense.
So let me tell you what I'm doing on Project X on the performance side. What I've done is I've put performance as the primary objective in everything that I'm doing. So it's the number one requirement.
If you think of SOSTA's new marketing for 2015, performance is everything.
Performance is everything, baby.
Yep. That's not a bad.
Yeah, it's a nice segue to our new sponsor, SOSTA. But yeah, if you put it first, and you will always accomplish it.
Yeah, I just want to add one more thing, Mark, on this one.
No,
so I don't know every way to design every single component, but there's this wonderful thing. You know what it's called?
Single malt scotch.
The internet.
Yeah, single malt scotch. While surfing the internet, and you can actually find a lot of interesting methods around design on many different code types. And if you just take 2 seconds and read things, and they're actually legitimate sites, not like, come here, buddy, I'll show you how to code.com or something like that. But,
Does that site actually exist?
I thought it was on the darknet.
It is on the darknet. It's absolutely on the darknet. Yeah.
Does it have a red light on it?
It might.
Yeah, a big red warning light. Do not enter this site. Do not enter this site. I mean, there's so much stuff. Even Wikipedia has something on program encoding optimization. So,
there's some of the great database design. Database in Depth is the one date book I have. And the same thing in all the database mentoring that I've had. Everyone would be like, I'm a great performance troubleshooter to fix your relational database problems. But ultimately, you would peel away, and maybe you could optimize things by 20%, 30%, maybe 40%. And the guys that were really good at it were like, if you really want this thing to go fast, we got to go back to the basic design of the objects and the entities and the things that you're doing, moving data around. Same thing in code. As a developer, you got to think about, where's my data? How do I most efficiently get it from point A to point B, move it through the system from the client to the server? Yeah. But the tip on the design thing is also, with an iterative methodology, you don't have to figure everything out. Maybe you're still doing an iterative approach, or maybe you're slowly getting pieces built together. But at least for each unit, we were just talking about web services in the last episode, maybe you're doing a collection of 2 or 3 web services. You'd think those through in terms of the long-term design. Keep your eye on the big picture, but don't halt all development until all design is done. But you got to kind of do them in real time, side by side.
Well, Mark, I think that's another great point about, and I was just going to bring that up, is yes, you can absolutely, optimize component wise as you're building it. It is definitely an iterative process, but you still need to understand the complete architecture and what you're trying to achieve.
Yeah. And as a developer, if you've never met with someone at your company whose title is architect, you might have a chat with them just before you kind of dive into the sprint.
I'm sort of surprised that someone with the title of architect didn't actually interview the developer.
There you go. Oh, exactly.
Novel idea.
All right, what's our next one?
Prioritize capabilities, implement and hardening according to value to the user.
That's a mouthful. What do you mean there?
What do I mean? Well, that's actually a great question mark. Let me tell you what I mean by that. Did you get the double entendre question mark? So, like, as I've said before a million flippin' times, I have been basically spending most of my time on consumer-facing websites, right? So what is the number one thing on a consumer-facing website is to get somebody to make the sale. How are you going to get somebody to make the sale? You got to keep them on the site, right? What's the way to keep them on the site? Offering them a positive end-user experience. Okay.
Now, Howard, I've got a question for you on this. I know that SOSTA has a big data analytics practice that's kind of coming online and looking at conversion associated with people coming onto a site, converting to the next step, how many steps they take, where they wait, how much time is spent, and can all of that data act as a giant feedback loop to this prioritization for what needs to be fixed, say, in the next release in order to improve conversion and capability?
Yes, James, absolutely. Not only is it that, but it should absolutely be used for you to prioritize how you're going to, I don't like to say test your site being a performance tester. How are you going to attack your site as a performance tester, right? It's going to help you write all your use cases. It's going to help you with your volumes. It's going to help you understand where your customers are spending most of the time on your site, right? So,
Yeah, so the one thing that this makes me think is that usually a developer, sometimes they are only given, they don't know what those priorities are.
Yes. So, we're kind of talking about all the marketing groups, everyone on to load all their different information to get whatever they want. And there's really a 2-second screen to screen. And there's kind of a key to doing some of this stuff. Yep. It's called deferred loading.
True. That's right. So if it's not absolutely essential for something to load, it'll be sort of put on the back burner, so to speak.
As advocate for marketing here, I want to say that we need to load these data analytics pieces first because we need to know if someone lands on the page but abandons the page before they get to loading of the object.
The reason they're abandoning the page is because it took so freaking long to get there.
Well, how about that they've got fantastic marketing analytics on a page that never loads? So there is no user experience.
I think that's HoCho on the part of the marketing. To be honest with you, because they need to settle on one data analytics piece to pull in all their data, and B, they need not be prioritizing a third-party service over their own revenue stream.
Potentially, right? Unless this is something where usually if someone is spending money on getting a performance expert to come help them and work with them, they're in a situation where they're getting concerned or the risk is going up. I think to your point, Howard, the being more proactive about knowing what's a priority on the page. If it's an e-commerce button, I can go check out step 1, step 2, step 3, and I hit the buy button. And those things have a priority in moving me through the flow. When I'm surfing around, maybe the product images in a catalog are really important. Maybe on a mobile device, knowing my presence or knowing my connectivity state is more important. So I think to a developer, put yourself in the end user's shoes a little bit. What would you want? What would you want? What would be a priority for you? And if you don't know, ask your product owner, ask your business analyst, hey, what really is the most important thing here in the order of the loading of a page or in a functionality within an app or a mobile app?
I mean, using the 20/80 rule is just a perfect thing to do here because it usually applies, right? 20% of your content on your page is going to get 80% of the traffic.
Yeah.
And true, and always prioritize your own content over third party. I think that's a good rule of thumb.
It's not a bad rule of thumb. There could be situations where they're doing an A/B test You're trying to decide whether if maybe a lot of the content is delivered through the third party. I would want to say it, but if it's inconsequential tracking, boy, you got to have a page to do something in order to.
So
track
what do you mean
it.
by A/B test? Do you mean like you're trying to decide upon two different third-party vendors to see who's going to be better when you're designing your site?
Sure.
Or if you're getting images from a third party versus hosting them yourself.
Yeah.
As an
Or
example.
it can be marketing placement too, Howard. Just sort of, we're gonna try maybe suggested items in an e-commerce site. These are like end caps.
Yep.
And you're gonna have dynamic end caps from a merchandising standpoint.
And to keep going on the subject, it's kind of funny. One of my favorite sites, I actually was doing some analysis on the site, and I just found all these marketing calls. And I finally went to them and said, guys, why are you loading all this stuff? You're complaining that your page, I'm not making this up, is taking 6 seconds to load your homepage. Yet,
I know exactly. It's all these third-party calls are from
they're
different
loading
groups.
like Facebook and Twitter and this, that, and the other thing. I said, why are you even loading this? Load it when somebody needs it.
Yeah, do it on a reveal. Do it on an Ajax control, where if they want it, it reveals it and it loads it in real time. And usually, some of that the user experience UI is going to be cached in a CDN somewhere if they're lucky. Okay, cool. So the next one you have here, I love this. It's very succinct.
Yes.
Own your code. What does that mean?
Performance requires ownership. Do not rely on or blame others to ensure the performance of your code.
So what's a developer, when a developer is not owning their code, what does this look like?
6 second page load times.
Yeah. So I
Anyways.
love this one, Howard.
I know
this
you
one.
do, James.
Howard, you and I are both kindred spirits on the the gasoline side of the universe.
Yes,
And
we are.
engine builders sign the engine. And for some engine builders, if the engine goes bad in the field, they put the engine builder on a plane with a mechanic's toolkit and send them to fix it.
Mm-hmm.
The problem with the whole organization owns performance is that no one really takes personal ownership for their piece of it. And they said, "Oh, the ownership is diffuse. We all like performance." But if you have actual ownership and you have consequences that if your code does not scale, if your code fails, that you take a personal penalty, you are going to be more attentive to the issues related to performance and scalability on that piece of code.
Yeah. James, there are some really easy things you can do to own your own code, right? So measure the time required to execute each unit and component assembly test. Fix what's slower than spec'd, or fix what's slower than on the previous build, right? Simple things to
Exactly.
do. All right, and then now we need to think globally
Right.
and act locally, okay?
Yep.
Assume a sparse resource condition for execution of whatever you're going to use, and just think that there's going to be a lot of shared resources out there. And by golly, when you allocate it, make sure you
Deallocate it.
hot damn. Da-da-ding. A prize. So the question mark.
Now, this next one, this tip you have on owning your code is testing for all positive and negative conditions. Now, again, a lot of developers don't even get into the nuances of the testing there. So how would a developer make sense of this, assuming failure will happen?
It's just pretty straightforward to me, right? You know how it's supposed to work, but there's going to be a lot of people who will push the envelope on, or people aren't going to do something right on your site, and you have to kind of anticipate what's going to happen when that happens.
So as a developer, just run it and starve it out of memory in the heap. Run it with a really small heap on your unit test.
Exactly.
And
One good way to do
let's
it.
face it, the three of us on this conversation, we're all reformed developers to a degree. And developers have one thing in common. They test to as built most commonly versus as spec'd.
Happy path testing.
Exactly. It compiles, it passed, 3 or 4 items.
Exactly.
Let's send it on. And that is the one thing that Mark, you and I constantly have hit in the past, is that developers are poor testers because of that. If we can make them better testers and have quality earlier on where it's cheaper to fix, it's a benefit to the entire organization.
Yeah. Now, Howard, another tip you have here is near and dear to our heart as a
I knew
database.
it would be.
Yes. You mentioned database-wise.
Yeah.
Collaborating with your database dev.
So one thing we should definitely do is, what you have a database, your database has a lot of capabilities. Why should you be writing code that duplicates what the database capabilities are? Leverage what your database can do. Use stored procedures.
So Howard, you're suggesting that we go back to the actual definition of client server, which involves some sort of shared processing model between client and server. How dare you, sir?
Oh, James.
Is my old school still shining through?
Yes, but do leverage the power where it need be. If you're pulling back a bunch of records into the app server, like an old SAP app server, right? And you're doing joins in hash memory on the app server, and then just throwing away most of that, you're creating GC storms and all. If you can do it faster from a central data source, it doesn't have to be a relational database. It could be any kind of data store. Do it, go where it can best be done. If you're going to do a bunch of hash aggregation, database is a great place to do that. App server, maybe not the best place to do it.
Agreed. And here's my last little one on owning your code.
Agreed.
I really love this one. Assume all of the code is running poorly, and you have to make yours the best.
Okay. So,
yeah, I'll buy that.
So sort of a little self competition.
Yeah, absolutely. Well, just not just self-competition. It's just friendly competition amongst your peers.
Yeah.
Right?
I like that. So own your code. Consider it that your name is going to go along with it as if it were an engine block being stamped.
So Howard, this next one, boy, it just speaks to me in ways that I really can't discuss publicly.
Does it make you smile, James, in just a fluffy, lovely kind of way?
Well, this is the week before Valentine's Day, and let's just say I'm a very happy man with this one.
Isn't it quite coincidental, James, that I was sitting next to you when I wrote this one?
There you go.
Perhaps coincidental. I will not take any credit for it. Maybe it's a bad example. Okay, we'll go with that. Yeah.
Okay, so don't attach discrete resource until absolutely required is a bad example.
No, maybe I'm the bad example.
Oh, you're the bad example. No, you cannot be the bad example because you and I agree that if you attach a discrete resource until you absolutely need it, then you're just going to add a whole lot of overhead and hog the damn resource from other people who may need it.
Yeah, so give us an example of this, especially for a developer who's probably not thinking about physical resources when they write their logic.
Probably the most common example I see on the internet of this is the default shopping cart. So here we have a logical example, a construct. Someone shows up at a store, whether they're shopping or not, you give them a cart and that's attached to them, and they have to take it throughout the entire system for the entire time they're visiting the site. That means the entire site has to be sized for all these carts, all these empty carts for the most part, when you know that your average user has about a 15% probability of adding anything to the cart. So if you were to simply allocate a cart at the time that they put something in it, think of a physical shopping center, you could make your aisles a lot narrower. You would have to have a physical inventory of fewer carts. You would have less wear and tear on your linoleum tile. I mean, all of these things.
I wonder if there's also, Howard, something like in the mobile world around network where people assume I'm going to attach the entire user experience depends on, sub-millisecond, sub-10 millisecond network latency from a mobile device, which is just insane. But they're testing and they're building the app inside the Wi-Fi in their office. They're not out in the real world. So they're attaching the entire experience to all these round trips on the network. Would that be another example of just doing a bunch of transfers for discrete connection to network?
Yeah, not only that, Mark, but it kind of segues into my next one, which is called minimize external crawls across the network.
Oh, who'd have thunk that was there?
What a
I didn't even read that,
segue,
honestly. Huh? That was it.
You
Mark,
didn't?
Clean setup, man. Clean setup.
I love that.
Yeah.
So look, number one, we all know this, or we should know this. Bandwidth costs money.
Big money.
Big money.
It can also cost you power. So if you start chewing a bunch of stuff across the wire and you're on kind of a weak link, you'll probably chew up all your battery to get the antenna actually running full power.
Well, that could be too.
Yeah, exactly.
But we don't have an unlimited network footprint out there, right? You only have so much bandwidth. And guess what? If you consume all the bandwidth with one transaction, what happens when you have a lot of people on there trying to access that single transaction?
And as a developer, you think about owning your code. And if you write your code in a way that the whole end user experience comes to a screeching halt on a slow link, if you go to development, if you go into production with that same code and suddenly they notice there's all these devices or all these apps and are waking up and sucking down tons of data, if you didn't build the app right, your ops guys are going to say, well, we need to start putting some throttles on this, right?
Well, hold on, Mark. As long as I get beyond the warranty period, as a developer, I don't care.
Whoa. No, there's no warranties. What the hell are you talking about?
Yeah, it's a bug warranty. If a bug shows up after 6 months,
I get my money back? What?
No, we don't.
No. If it's in production longer than 2 or 3 weeks and no critical bugs show up, it's on ops to pay for it. It's not on dev. It's beyond the warranty period now.
But then you've given them such limited options. The ops guys will just put a throttle, and it's QoS. That's what QoS. I'm thinking
quality of service.
No, I'm sorry. We can't do that because we have net neutrality. We can't prioritize packets over each other.
But you may throttle things down. Like if you've ever tried to download something from the App Store and it just takes forever because your app is huge, just the installation routine could take forever if you're on, a 4G or even an LTE. So QoS to me, if you have to turn to QoS to try to get things to work smoothly, to be honest, it's probably a poor quality of service that you're guaranteeing because you've got apps that are running wild and becoming hogs. See the previous point.
All right. So, hey, the next thing you need to do is understand the payload size that you're sending per packet and understand the number of app turns you're using per transaction. If you balance your payload per packet side, you'll achieve excellent performance gains. What the hell do I mean by
Howard,
that?
if I could paraphrase, so we have roughly 1,500 bytes per frame going back and forth across the internet. If I was to balance out my send and my receive to minimize the number of frames that I would have to use, so I wouldn't have to send any fragmented frames or anything of that nature, and really, really compress tightly the information I need to just its essential core.
Yeah.
I could achieve higher performance because I would have a less dependency on the network. Is that what you're telling me?
Yeah, that's definitely one of the ways you can do it. But also, James, sometimes you have to get the payload across, right? Let's put this over. We're dealing over a long distance. We have a lot of latency. The more app turns, the longer it's going to take to get the information through, right? So you really kind of want to limit the app turns you're doing per transaction. But on the other hand, too, and I may be saying what you just said, to do that, you're going to have maybe you'll have a little larger payload size, but unfortunately.
So maybe this goes back to your issue of appropriately splitting workload between database and client, and instead of issuing a complex transaction which involves you receiving data, processing, sending another request, processing, and sending a third request, that you call a stored procedure to send one request, have the work done on the server, and then send one payload back.
Yeah.
I also think that
Absolutely.
There's some really savvy folks building apps that work both in enterprise over Wi-Fi or out in the wild, and they start to be more adaptive. There's actually frameworks you can build on that could switch between stuff. So if it's got really healthy, fast network, it'll do more chatty things. If it gets out in the world, it'll queue those messages up and send them just with one turn, which is pretty cool. And it's not that you shouldn't think about it; you should still think about it.
Mm-hmm.
But yeah, that's a really good point.
So I have one more point on this, and that's whenever possible, take advantage of sending your data through multiple network ports.
Oh God, yes.
Yeah, right. Yeah. So parallel transmissions are going to be huge, especially important if you're going to be using, as we all are, TCP protocol, right?
Yeah. A lot of people say that at least on the HTTP level, that the whole sharding thing is just kind of a thing of the past. And I like, it's just sort of, sharding is never what it would, don't go more than like 4 shards if you're going to do it. And I just think that's because of the browsers of the days past, 10 years ago, were so limited on connections that you couldn't parallel things much more than that. Well, now you've got browsers where the defaults, I think, are what, 9, 8, 12 connections coming, like Firefox, the latest one, I think, is 12.
It's 6 per host. It will expand at the very beginning to 10 per host.
Yeah.
So if you're going across 6 hosts, 10 resources per host, you can actually hit the parallelism pretty high. As an example.
Without sharding.
Yeah,
you could still, because you can get so many things in parallel even from a single host. So I think that's why the myth of sharding has sort of come to an end, just because we've changed the client so much. But that to that end, Howard, your point is you could still overdo it. You've got a multi-lane freeway of network connectivity coming out the back of the client. If you issue a request that goes across all these ports, you could end up saturating that network. And again, you're not the only one on that machine.
Absolutely.
Very cool. All right, guys, we'll take a little break from our sponsor and then come right back and continue our riveting conversation to all you developer engineers who need to learn about performance.
Lightsquare.com is a proud sponsor of PerfBytes. Lightsquare is a unique offering for performance tuning as a service for web architectures. Lightsquare delivers tuning recommendations in under 72 hours without the typical investment in tools, license fees, or consultants, where we do the work up front. With Lightsquare, you only pay based upon the level of improvement. Find out more about Lightsquare's unique pricing model at litesquare.com/pricing.
Okay, now ready for part 2, Howard?
Yeah, so this one's kind of an obvious one, at least to me.
Yeah.
Minimize your writes to disk.
There's a lot of developers who don't even understand what or where a disk is.
Well, first of all, you have to understand this. I think probably disk I/O is one of the most, what's the word I'm looking for? From a computer world, I'd say the most labor intensive, because it's all really physically writing on and off the disk, right? Mm-hmm. So you'll have things like spindle speed to worry about. Since a disk is an electromechanical device, spindle speed, as I just said, plays a major factor in the ability to enter and retrieve data from a disk.
What about SSD?
Well, SSD is absolutely going to be faster now, right?
Well, it's going to be faster. It still has limits, though.
Exactly. You're still going to have to limit the speed of the SSD, right?
Yeah.
So any of our performance test community can actually test this hypothesis on minimizing writes to disk by getting a load generator that works really well, and all of a sudden change it from no logging to log everything.
This is, I gotta say, Howard, that's the biggest thing when I think of an app developer, is that they put things in info level logging that really should be reserved just for debug.
Yes,
I find it all the time. And let's say you're unlucky enough to deploy this application into production where all the logging is over NFS. And that is, you're taking disk writes and network, the two slowest resources, and just blasting them with log messages. That's got to be the biggest one in terms of write to disk. If you're a database developer, well, now you got to think also about a totally different kind of disk, right? Because you're looking at data commits and whether you have to do full scans or seeks, whether you're hammering a temp DB, because temp objects will hammer a temporary database as well if you don't have the memory.
Well, plus you've got lock issues, whether you're going to lock a database, a page, a row, a cell. If you're going to have your indexes on a separate higher speed form factor for drives versus your data, and all of those things.
So what kind of tools, Howard, should a developer pick up? Because again, looking at disk might be a little foreign to them when they live in their IDE and code land.
Yeah, so one thing, there's actually a good alternative out there, Mark, and that's like, instead of putting it into disk, why don't you think about writing it into memory?
Okay.
Just think of this analogy, right? Latency factor of memory can be compared to an F-18 Hornet, right? The F-18 Hornet's max speed is like 1,190 miles per hour, 1.5 times the speed of sound. This would compare to the latency factor of disk I/O with the speed of a banana slug. The banana slug has a max speed of about 0.0007 miles per hour.
And if there's salt involved, it's even slower. Right?
Yeah.
That's cruel. I'm against the cruel punishment of banana slugs.
Kind of one tool would be just to start writing into memory versus using a lot of disk I/O.
Yeah, exactly. And you can, obviously every operating system, even the development toolkits you have for mobile, you can see what's being written into the flash memory space on the mobile device, something that's persistent from one app session to the next. I mean, mobile devices have storage, and it is being written. Maybe not on a spindle, but it is being written there.
Yeah, another interesting fact, too, is, thinking about I/O speed effect on performance is the fact that how disk I/O is prioritized within an OS.
True.
Yeah, it's the go back to Intel operating system architecture, Ring 3, Ring 1, or Ring 0.
Mm-hmm.
This I/O interrupt, this hard interrupt, has a higher priority and must be handled immediately. And it is to the deference of any applications which are running. So as soon as you say, I have to write to disk, that is, application behavior is suspended, I write to disk, I come back. So the more of that interruption that you have in the system, that is less CPU and less activity for the actual applications which are running, which are of interest to the users.
I wonder if that prioritization within an operating system kernel is actually a hangover from the days of really slow disk. Like they had to prioritize it back then because they knew it was going to take a long time and everything else needed to sync before you had a I/O commit.
I'm trying to remember back to what I remember the slowest disk I ever worked on spindle speed was.
That would have been like a PDP-11 disk pack, wouldn't it, Howard?
Oh, yeah, absolutely. A removable disk.
I was on a disk once that wasn't spinning.
You're on a disk that wasn't spinning?
Yeah, it was the slowest it could go. It was just frozen. The IO's never committed.
Well, the old days too, you talk about PDPs. Now you got me going back. I remember this one drive. It was called an ARM05. If you had a head crash, you'd have to replace 14 heads and then align them all.
Yes. Now, if you're on an iPad or a Galaxy tablet or something like that, and you're looking at flash and SSD, I wonder if these modern operating systems, more modern in the last few years, they've changed sort of that prioritization on I/O. They're probably thinking more the same way around network in the mobile world. Is like, we have to prioritize getting our network stuff done, or we're trying to do that more asynchronously.
Well, Mark, network and disk have the same priority.
Really? Okay.
As far as Ring 0. Now, there's a cost associated with each. But as far as prioritization from an operating system perspective, you've heard of INTs versus IRCs.
Oh, yes.
Concept of interrupts. You have a hardware interrupt or a software interrupt, and the hardware interrupt always takes priority. It's something that needs to be handled because the software interrupt can be queued.
Yeah, and it's all part of keeping the kernel happy first until it can serve up user mode stuff.
Yes.
Totally. All right. What else we got, Howard? What do you got here?
Now, number 8 in the great 10 would be consider language-weighted code for efficiencies. Choose a lighter weight language for a heavier weight job.
Now, Howard, you and I have had pretty extensive discussions on this. This whole issue of .NET, C# versus Java versus C versus PHP versus
Ruby.
language du jour, all of this sort of stuff. Yes. And I really wish there was more, there was more literature that would benchmark given algorithms in different languages so we could see the efficiency curves for language A versus B. And I've been looking and there's not a whole lot out there unless you go all the way back to like Fortran versus assembler versus C.
Well, I wonder, guys, if there's a way to just separate them a little bit, where you take something that is a totally compiled language like C and C++ versus that where you have to roll your own memory management and you have to do it all yourself and clean up after yourself, versus another framework base like the CLR and .NET or the JVM, where you're looking at garbage collection based memory management that's sort of asynchronous from the running of your code. versus, let's say, more interpreted type languages, right? So you've got wrote it in Perl or Python. And then the database is a whole other part of the language where you'd write something more native within the database itself, or you'd write scripts that run on top of the database. So maybe we, at a high level, what would be the three categories would be something that's written in like C and C++ or Object-C. Then you'd have framework-based languages where you could pay those costs and maybe the session stays around, the objects live a little longer and they don't have to collect that much, or you move stuff in scripts.
Now there is a lot of debate on this, because if you go on various forums and you look up C versus Java performance,
okay.
I mean, there are a lot of people that say, hey, C approaches the speed of Java. I don't see it. I mean, conceptually, I just don't get it, because you've got C as a compiled language, particularly if you have an optimizing compiler, very small, very tight, very fast code. And just from a Java perspective, you have object-oriented inheritance, and you have a lot of fluff in that, even if you have a highly optimal Java virtual machine. But some people have suggested, and I'm not sure I buy it, that you can get very close to linear performance until you get to the ragged edge on scalability. Yeah. I would like to see more of this type of basic research of C, C++, Java, C#, VB, Perl, PHP, because there's going to be a language that is an optimal fit for a solution. And I got to say, for some solution, it might be SQL. It might be PHP. That's the fastest possible solution. But we lack a lot of basic research in this area.
Well, James, I've actually found a couple of sites out there that do discuss this. So LMGTFY, and you could probably find it.
But if you want to get into a war, show up and say, insert language here is the fastest and the best available, and you're going to get shot at. That's for sure.
Yes, that's be good. Well, to be honest, a lot of developers usually don't, unless they're super senior guys like us. Most people that are developing, they learn one or two languages, and they're sort of, once you have a hammer, everything's a nail. So let's start with the language that you know best. Let's say you're a JavaScript coder in PHP or JavaScript and Java. Boy, study it so that you know the most optimal way to build that code before you actually put it in the app. Don't worry about learning every language that's out there. Although, James, I think you're right. There could be a better benchmarking consortium that could put that together. Know the language that you know best, and know what things are slow and what things are fast, what things to avoid, what not to do in JavaScript or what not to do.
No, I think, Mark, that's an awesome point. Just knowing like if you're kind of into one or two different languages, and I'm not going to say if that's good or bad, it's just the fact that you at least know how to optimize within the language that you're using and accustomed to.
Or pitfalls, what to avoid.
Yeah, exactly.
Absolutely.
Okay. So we have another public service announcement, but I'm gonna switch things up here to the public service. Which public service announcement you guys want for this episode?
I want the one about the cool kids tested in production.
You know them. You see them hit the end of an iteration and they just plain ran out of time for performance testing. You hear them convincing the VP of development to just fire all the testers. You see some other kids aren't testing at all. And you see the cool kids, well, they're testing in prod. It can be tough under all that peer pressure just because you want to be cool too. But being cool isn't as important as it seems. PerfBytes encourages you to keep your own commitment to quality steadfast and not give in to those trendy, cool hipsters who don't know how to test and who, by the way, don't pay for what happens in prod. Stand your ground against emergency promotions and too fast releases directly to production without any testing whatsoever. Know that PerfBytes supports you because friends don't let friends deploy without testing.
And I'm still one of the cool kids because I get to test in production.
Yes, you are. That's right. All right. So that was pretty riveting, actually, talking about, developer, whatever the it was we were talking about. Oh, languages. That's right.
You just use bad language.
It's very efficient.
Bleep.
I know the
Bleep.
language. I made a choice as to what language I was going to use there. So one of the biggest things, especially with more framework-based, or let's say you're writing a Ruby on Rails stuff, there's a lot of people that don't know how to write core code, like system-level code, to do things. A lot of developers now, they've never written their own memory manager. They don't code a linked list and anything. They just move data around, A to B, move it from here, move it there, move it here, move it there, and they deal in everything's a string. So, Howard, this next one you bring up is really looking at string conversion. And, of course, if you think of everything being a string, every payload on a web service call, JSON, fields, name, value, pairs, whatever it was, all these things come back and get parsed up and chopped up as strings. So what's your real disadvantage that you're pointing out in this?
Well, not being able to subclass a string means that it's not possible to add behavior to a string for your own needs, right? This means that all access must be through the restricted set of current availability string methods imposing extra overhead.
And Howard, let's talk about what the basis of this is. There is no native string handling capability in a processor, so everything has to be converted in order to be processed anyway. But if you start doing type conversions, so I'm converting string to integer, integer back to string, or any other type of conversion, this is very CPU heavy, and this will just pin your processor very quickly under load.
Absolutely.
So what should a developer do then with this stuff?
Treat it natively.
Treat it natively.
Yeah, when it comes in, automatically put it in integer or other type of format that is actually native to the data that you're using, versus treating everything as a string and then doing operations on a string.
Yeah. What else do you think there, Howard?
Yeah, what about string to numeric conversions?
Those are very expensive. Now, most developers don't really care about that because it's CPU is cheap. We could just add more processing capability. But if you're in the cloud, let's say you're in AWS, they charge you for every CPU cycle.
Yeah, so that it directly goes to money. I think, Howard, you made a point here also about using string buffers, which like using a string builder object. And working with string manipulation, they've already optimized some of that code within, say, .NET or Java in the framework. So versus rolling your own strings and parsing and converting everything yourself, when you're in those frameworks, that can be really costly. Using a string buffer, what's the advantage of that a developer should think about?
Well, string buffer with the capacity of 10,000 characters can build a string of 10 characters. However, that 10-character string continues to use a 10,000-character array to store 10 characters. If the string buffer is now reused to create another 10-character string, the string buffer first creates the new, wow, what a mouthful.
That's huge.
Isn't it?
Yeah.
Well, it's almost as big as a 10,000-character array string buffer.
So essentially, you're allocating early things you don't need. Going back to one of your earlier recommendations to developers
is don't allocate it until you need it.
Yeah, and if there's no other option, then you just leave it out there in garbage collection. These are the things that get pinned and hung on to outside of that container in Eden, and they never get collected, and then it blows out GC. So there are advantages to using a string builder object versus a raw string buffer. I think that's what.
Yeah, and then other things you can do too is. There are a number of methods of allowing efficient manipulation of string characters, and that would be like copy the characters into your own array and then manipulate them directly, in which case the string is imposing an extra blah, blah, what? What the did I mean when I wrote
Nobody
that?
knows what you meant, but we're working through it together. We're in it together with you, Howard.
I know.
Yes.
This was a long time ago.
You're limiting your overhead on the operator because you only have the exact number of bytes that you need, as opposed to the extra 8,000 characters that you don't.
Well, here's the other tip, though. If, again, you think globally and act locally, if this is something where you'd have, malloc or memory overruns, where somebody would create a very specific sized array, and then all of a sudden they're like, oh, wait a minute, I started shoving too much stuff in there, and, all these other errors. If you were in C or C++, this is where things just blow up. Whereas, we try to solve those low-hanging fruit errors by throwing around as frameworks. All right, well, hey, look, we'll give you 10,000 characters.
Mark,
and away you go. What?
Mark,
what?
My C code doesn't blow up.
Well, that's because you test it. It's not fair to developers who don't know how to test.
Never mind. I rescind the comment.
Yes, there's more to testing than just hitting the compile button. We know that. All right, Howard, what's our final? This is number 10, our final tip for a developer.
I know James and Mark, you're both going to love this one. Caching is not a solution to bad design.
That's caching spelled with a CH.
Yes, not SH. Well, caching is a good solution to my pocket, but...
Sure, yeah. Actually, if you want to pay the performance testers or hardware guys a lot of money, then you won't use caching at all, and you'll buy giant network pipes and really fast servers all over the world. So it's one of the number one things on News of the Damned where people don't survive point load.
There are like a lot of points here, but some of the highlights, there's a latency cost associated with caching. And this cost increases with each level of caching used, right?
Okay.
L1 cache hits, going to give you a couple extra cycles. L1 cache missatisfied by L2 cache hits can cost you 8 to 10 cycles, so on and so forth.
Well, you're talking about like in-process memory caching as well.
Yeah, absolutely. I mean, caching. There's a worldwide of caching sports out there.
Oh, that's true. But yeah, so if you very rarely developers now really even understand a physical processor architecture with L1 cache, L2 cache, processor cache on the chip. A lot of guys live in the virtualized platform of everything is shared, and I don't have physical access to anything. I've seen some really, really crazy configurations for Eden or Generation 0 in the CLR, and they're like, we're running on a virtual machine. There's nothing physical about it.
And I will admit that I wrote this in the old days too, so some of it may not be as relevant today as it is yesterday. But
still relevant for somebody that's writing a native app even on a mobile device. Mobile device, even ARM processor has processor cache. Mm-hmm. So if you write a mobile app that's doing something and you're blowing out that itty bitty teeny weeny little processor cache memory space, boy, that's you're right back to the old days of writing native code running in the kernel physically. It's not a virtualization layer like in the server compute. James, what are your thoughts?
Amen.
That's it?
Yeah, pretty much. Yeah.
I think the 10 war is out.
But your point is caching is not a solution to a bad design. So we go all the way back to point number 1, which is start with a good design.
Exactly.
Where does your data live? Where does it need to get to? Where can you store some of that along the way so you don't have to make the round trips anymore? Can I save something local, manipulate it local, and then when I'm done with the transaction, then commit it all the way back in? Now, this would be different than a CDN.
And it still goes back to, and I'll be a broken record on this till the day I die. If you don't understand your architecture, how the hell are you going to build anything?
Yeah. Very good.
So Howard, I think you have some final thoughts.
The closing thoughts.
Outside of the 10, but, kind of some rules of thumb to live by.
Yeah, my favorite one is just remember, if you allocate it, by golly, don't forget to deallocate it. The other thing is if you pack it in, don't forget to rip it out.
Okay.
That one almost deserves a rim shot, but go ahead. Yeah.
Those are my biggies.
Yeah. James, you got any biggers there?
Don't rely solely on garbage collection. Don't over dispose, and remember, just because if you're a bad developer in C, you're going to be a bad developer in Java. You still have to mark it to be collected.
You still don't do something that unnecessarily connects outside to another object and attach a hard interface to something where it's like, well, you can't collect me. Yeah. I'm still being used over there.
So Mark, your final salient thought out of these 10.
No, you should. I'm not advocating that. But anyway, unless you absolutely need to. I think there's an old adage that goes back, and it's very relevant and agile, where used to say, thou shalt not prematurely optimize one's code. And I think going back to Howard's first couple of points, if you don't see a response time requirement or a volume requirement or a performance type requirement or desirement written in the user story. Like if there's not a product owner or a business analyst or a customer, an end user that says, I really need you to optimize this part of your code, or we're going on to a new platform that has less power or less disk or less resource. If you're just kind of optimizing and trying to make things go fast in a vacuum, you will be seen, even if it's the right thing to do to make us happy or make you happy, or if you don't have a requirement to do it, if nobody's going to see it and say, that's great work, you are really wasting your time. And unfortunately, that means you may not be in an environment that actually believes in good performance. But if you are missing a user story or a spec that says you have to meet these following latency requirements or volume requirements, go build them. Go talk to somebody and say, hey, I'm concerned that this thing's not going to go fast enough. To your point, Howard, we're way over 2 seconds just for my one little call on this component.
Yes, you are. Don't
prematurely optimize your code. But if you want to optimize your code, go find a customer, find someone who cares in your company and say, I think we should focus on performance. All right. Well, PerfBytes listeners, once again, you've come to the close of another reverse engineered and decompiled episode of PerfBytes. And as always, we'd like to thank all of you in the PerfBytes engineering world for taking the time to listen to the show today.
Mom, thank you for tuning in and welcome back from Panama.
Howard.
I'd like to say thanks to my hand surgeon. I can actually type pain-free in my right arm right now. Next, on to the left arm. And thanks to my wife, as always, for taking care of me while I was recovering from my hand and elbow surgery.
Yes, I'm glad you're feeling better on that.
I am indeed. Now we can do the other side.
And as always, thanks. I will say thanks to the sexy Irish voice of PerfBytes and give a special thanks to our great sponsors, Smart Bear Software and Sosta, for their sponsorship and support of the PerfBytes show and PerfBytes community.
Mark, Howard, today's show is powered by Blood Rare Steak and a whole box of red wine. Don't forget to order your Valentine's gift from Pajamagrams. Go for the hoodie footy. You're sure to have a good time with that. And oh yeah, those Sherry Berries things too. Be sure and use checkout code PerfBytes.
There are no Sherry's Berries.
And please remember that all the contents of this PerfBytes episode is copyrighted and protected by my cousin Vinny, Sal, and Guido. So no funny stuff. Capiche?
Capiche. You know, Howard, speaking of your cousin Vinny, you know, the 1963 Pontiac Tempest had 2 equal-length tire marks for positive traction, right? I mean, you can't make those marks without positive traction, which was not available in the 64 Buick Skylark.
And why not? And what is positive traction?
Well, Howard, it's a limited slip differential which distributes power equally to both the right and the left tires. The 64 Skylark had a regular differential, which anyone who's been stuck in the mud at Alabama knows. You step on the gas, one tire spins, and the other tire does nothing.
Really, James? Is that all?
No, there's more. You see, when the left tire mark goes up on the curb and the right tire mark stays flat and even, well, the 64 Skylark had a solid axle, so when the left tire would go up on the curve, the right tire would tilt out and right along the edge. But that didn't happen here, so the tire mark stayed flat and even. This car had an independent rear suspension. Now, in the 1960s, there were only 2 other cars made in America that had the posi traction and independent rear suspension and enough power to make these marks. One was the Corvette, and that could never be confused with the Buick Skylark. The other one had the same body length, height, weight, width, wheelbase, and wheel track as the Skylark, and that was the 1963 Pontiac Tempest.
Wow. For more information about PerfBytes, visit the show's website at http://www.perfbytes.com or follow us on Twitter and Facebook. And of course, you can always subscribe and listen to PerfBytes podcast on iHeartRadio, iTunes, TuneIn Radio, Stickler, and testingpodcasts.com. Just open your favorite listening app and search for PerfBytes. Click the subscribe button or favorites button or whatever button you happen to have at your fingertips at the present moment.
The PerfBytes Show and staff are supporters of the Practical Performance Analyst, the Performance Engineering Book of Knowledge, the Computer Measurement Group, the workshop on performance engineering and reliability, and of course, the Software Test Professionals community of software testers. We hope to see you at the next STPCon conference in April of 2015 in San Diego. Check out more at www.stpcon.com.
And of course, just like with Sandeep on the last episode, thank you for listening to everyone. Remember, you can email your questions and your comments to us at ask@perfbytes.com. Send us a question, send us a comment, send us a topic that you'd like us to cover, and believe me, we will do our best to get it all wrong. At least we would be entertaining. Thanks, everyone, for listening. We will see you, and have a great week.
Hasta mañana.